Hello everybody, welcome into another lesson. So today we are going to talk about dividing monomials. So far we've added and subtracted them and multiplied them. Now we're going to divide them. So if you have any arbitrary base a raised to a power in the numerator over that same arbitrary base a raised to another power in the denominator, so we called the first power in the numerator m, the power in the denominator n. If the power in the numerator is greater than the power in the denominator, then it's just simply going to be that base to the power in the numerator minus the power in the denominator. That's if the power in the numerator is bigger than the power in the denominator. It's simply going to be that base to the power in the numerator minus the power in the denominator. If, on the other hand, we'll take that same base and the same powers, but the power in the denominator is bigger than the power in the numerator, then you're going to have 1 over the power in the denominator minus the power in the numerator. That's if the power in the denominator is bigger than the power in the numerator. And then if you have the same base and both powers are equal, of course you just get 1, because anything divided by itself is 1. So that's a synopsis of that, where we're going. So let's get started here. We'll do it with some numbers first. Say you have 10 to the 4th over 10 to the 6th. So you got 10 to the 4th over 10 to the 6th. Well, I can tell you now the power in the denominator is definitely bigger than the power in the numerator. 6 is greater than 4. So what you're going to have is 1 over that base 10 to the 6 minus 4. You'll have 1 in the numerator and then the base 10 in the denominator with the 6 minus 4, because you'll take the power of the denominator minus the power of the numerator. Which 1 all over 10 to the 6 minus 4, that's 1 over 10 to the 2nd, which we know 1 over 10 to the 2nd, that's going to be 1/100th. So the answer we should get for this would be 1/100th, or 1 over 10 to the 2nd. Alright. Let's say we have 10 to the 9th over 10 to the 7th. So we have 10 to the 9th over 10 to the 7th. In this particular case, the power in the numerator is bigger than the power in the denominator, because, well, 9's bigger than 7. So you'll just keep your base 10, and you'll take that to the power of 9 minus 7. You'll take that to the power of, that's in the numerator, minus the power in the denominator. 10 to the 9 minus 7, that equals 10 to the 2nd, which we know 10 to the 2nd is 100. So the answer you should get for this would be 100. Alright, we have 12a over 3a. What I would do first, what you can do is you can take, since you have coefficients on each of these terms, what you can do is take your 12/3, multiply that by a over a. Because you can treat, because the 12 times a, and then there's 3 times a, So you can split these up into 12 over 3 times a over a. You can kind of make these their own terms. Well, we know 12 over 3 is what? That's 4. A over a, they're both of the same power, it's just 1. So the answer you should get is simply 4. A over a would be 1. So yeah, the answer is 4 for that. Let's say we have 10m over 5m. So we have 10m over 5m. I would treat the 10 over 5 as its own term, then multiply that by m over m. So you can take each of these, the 10 over 5 and then the m over m, make them their own term. Sometimes it helps to split the variable from the constant. That can really help you out, because pretty soon here we're going to be dealing with multiple variables, and you're going to want to have multiple multiplication problems to really piece it together. If we try to do it all at once, it can get kind of messy, so that's why I'm splitting it up. But we know 10 over 5 is what? 2. M over m, well, both m's are to the same power, that'd just be 1. So 2 times 1 is 2. The answer you should get is 2. Alright. Now here's where it starts to get interesting. We have 4x to the 5th over 8x. So we got 4x to the 5th over 8x. What I would do, still go ahead, split up your coefficients. You'll have 4 over 8 times your x to the 5th over x. So if we deal with the 4/8, we know that's 1/2, right? 4/8 is 1/2. Now, we have x to the 5th over x. The power in the numerator is clearly greater than the power in the denominator, so you're going to take that base x, set it to the 5 minus 1, which would give you 1/2. Then x to the 5 minus 1 is x to the 4th. So two ways you can write this. You can write it as 1/2 x to the 4th, or you can write this as x to the 4th over 2. Either way is acceptable. You can write it either way, because 1 times x to the 4th is x to the 4th, and you just have that denominator of 2. So you should get half x to the 4th, or you can get x to the 4th over 2. Either answer is acceptable. Alright. 3n to the 7th over 15n to the 3rd. So we got 3n to the 7th over 15n to the 3rd. What I would do, take your 3/15, split that up, take that times your n to the 7th over n to the 3rd. As I said, for me, until you get used to this, once you get used to doing these, you'll be able to do it in one foul swoop. But for now, if you're newer at this, I would go ahead, split up your constants from your variables, okay? Make it 3/15 times n to the 7th over n to the 3rd. Well, we know 3/15, that's going to be 1/5, times, okay. It's clear to see again, we have n to the 7th over n to the 3rd. It's pretty clear the power in the numerator is greater than the power in the denominator. So you'll take that base n, you'll take that to the 7 minus 3, which would mean you should get 1/5. N to the 7 minus 3 is n to the 4th. So that'd be one acceptable answer. or you could write it as n to the 4th over 5. You can write it either way. So that's what you would get. Interesting one. We have 12y to the 3rd over 4xy. Well, all of a sudden we have two variables. So what you're still going to do, split this up into 12 over 4 times. Now we have nothing for x in the numerator. We only have it in the denominator. So assume your numerator is 1. Make the default numerator 1, your denominator be x, since x is in the denominator. Then you're going to have times y to the 3rd over y. So yeah, split each variable up too. It's going to make your life a lot easier. Now we know 12 divided by 4, that's 3. You'll have that times 1 over x times, now we got y to the 3rd over y. That's going to be, again, where the power in the numerator is greater than the power in the denominator. You'll take that times y to the 3 minus 1. So what you would get is 3 times 1 over x. Now you got times y to the 3 minus 1, that'd be y to the 2nd. So if we go through, multiply all this together, you just multiply your numerators, you'll get 3 times 1 is 3 times y squared is 3y squared over that denominator of x. So the answer you should get is 3y squared over x, because you multiply your numerators. 3 times 1 is 3 times y squared. That's 3y squared over that denominator of x. So you'll get 3y squared over x. So yes, I think the bite-size method I'm teaching, I think that's the best way to approach these if you're newer at this and unsure. Alright, we got 3r squared s over 9rs squared. Alright, we got constants and two variables. So what you do, take your 3/9 times r squared over r times s over s squared. Alright, let's deal with our constant first. Our constant's 3/9. We know that's 1/3. Now deal with your r's. The power for r is clearly greater in the numerator than it is in the denominator. So you'll have that times r to the 2 minus 1 times, what's your s power? Well, in this case, for your s powers, the power in the denominator is greater than the power in the numerator. So you're going to have a numerator of 1 over s to the 2 minus 1. Because whenever the power is greater in the denominator, it's 1 over that base to the power of the denominator minus the power of the numerator. So let's go ahead and simplify this further. You'll still have 1/3 for your constant, that hasn't changed, times r to the 2 minus 1, that'd just be r to the 1st, or just simply r, times, you have 1 in your numerator, but over s to the 2 minus 1, that'd be s to the 1st, or just simply s. Okay, so let's go ahead, let's multiply the numerators first. You have 1 times r, which is r, times 1, which is r. So your numerator is going to be r, your denominator will be 3 times 1, which is 3 times s, which would be 3s. So the answer you should get for this would be r over 3s. That's what you should get in the end, r over 3s. Alright, 42 y z to the fourth over negative 48 x z cubed. Alright, now we have three variables we're dealing with, so it just got very interesting. First, you're going to, again, do your 42 over negative 48, or if we remember, if we have a negative in the denominator, we can simply move it to the numerator. That'll make your life a lot easier. You'll have negative 42 over 48 times, alright, do you see, we see an x in the denominator, but we don't see one in the numerator. So your default numerator for that, for the x part, will be 1. You have that over 1 times x times, now we see a y in the numerator, we sure as heck don't see it in the denominator. So your numerator would be y, your denominator would be 1, because you don't see a y in the denominator, times, you got z to the fourth over z to the third. Okay. First, let's deal with our constants, our negative 42 over 48. What is the greatest common factor of 42 and 48? I'm going to say it'd be 6, right? If we take negative 42, divide that by 6, you'll get negative 7. You divide 48 by 6, you should get 8. So you'll have negative 7/8 times the 1 over x, that hasn't changed, times your y over 1, that hasn't changed. Now, we have z to the fourth over z to the third, so clearly the power in the numerator is greater than that of the denominator. So you're going to take your base z, you'll take that to the 4 minus 3 power. Alright, so let's go through now. You'll still have negative 7/8 times 1 over x times y over 1 times z to the 4 minus third, that'd be z to the first, or just simply z. I think now we're ready to go ahead and put this together and form our answer. So start with your numerator, negative 7 times 1, that's going to be negative 7 times y, be negative 7y, times z will be negative 7yz. So you'll get negative 7yz over your denominator of 8 times x, which is 8x, times 1, which is 8x, times 1, which is 8x. So the answer you should get for this would be negative 7yz over 8x. That's exactly what you should get. So this is why, in between basic math and pre-algebra, I've been preaching about being able to factor constants, because it's so important for now to be able to factor constants, because we're going to be heavily focusing on variable terms and monomials. Alright, a little bit easier one. We have xy squared z cubed over x cubed y squared z. Alright, so we got xy squared z cubed over x cubed y squared z. Again, split these up into, since you have three variables, I split them up into three separate fractions and that you multiply by each other. So your first one's going to be the x over the x cubed. You'll take that times your y squared over your y squared times your z cubed all over z. See, this one's great because you have all three power rules for dividing monomials at work in this one problem. So, for the x part, it's clear to see that the power in the denominator is bigger than the power in the numerator. So you're going to take 1 over that x to the 3 minus 1 power times, okay, you have y to the second over y to the second. Well, since they're the same power, it just goes to 1. You can make a denominator of 1 if it helps you. 1 over 1's 1, we know that. Times, now you got, with the z terms, it's clear to see that the power in the numerator is bigger than the power in the denominator. So you'll take your base z, you'll take that to the 3 minus 1. So what you'll end up having here, if you simplify this, you'll have 1 over x to the 3 minus 1. That'd be 1 over x squared. I don't even think we need to repeat the 1 over 1. That's gone, it's 1. You'll have that times z to the 3 minus 1, which is z squared. Now all you got to do is multiply your numerators. You'll have 1 times z squared, that's just simply z squared, over your denominator of x squared. So the answer you should get for this would be z squared over x squared. That should be the answer you get. All right. Let's see. We have 32a to the second b c to the third over 20abc. Alright, so we got 32a to the second bc cubed over 20abc. Well, there's going to be 4 parts of this because you got your 32 over 20, so take that. Take your 32 over 20 times your a squared over a times your b over b times your c cubed over c. Alright, so we've split this up into 4 separate terms in a multiplication problem, making your life a lot easier. Let's deal with the 32 over 20 first. What's the greatest common factor of 32 and 20? I'm going to say 4. So if you divide 32 by 4, you get 8. You divide 20 by 4, you get 5. So you'll have 8/5 times, now for the a part, the power in the numerator is bigger than the power in the denominator. So you'll take that base, you'll take that a to the 2 minus 1 times, you got b over b, it's the same power, so that just goes to 1. I'll say 1 over 1 for the denominator. Times, now you got your base c. It's clear to see that your base c is going to be greater in the numerator than in the denominator, so you'll take that c to the 3 minus 1. So let's simplify this a little further. You'll get 8 over 5 times that a to the 2 minus 1. Well, that's just a. 1 over 1, that's 1. Let's just not even worry about that because it's just times 1. But c to the 3 minus 1, well, that's c to the second. So what you should get as your answer, let's go ahead and do your numerator. 8 times a is 8a times c squared is 8ac squared, all over that denominator of 5. So the answer you should get is 8ac squared over 5. I don't think we'll have too many more. All right, let's see. Let's say we have something like this. A plus b to the third over the quantity of a plus b to the second. Well, it might look confusing because now you have a sum of two numbers inside parentheses raised to a power. What you can do, though, you just treat that a plus b inside the parentheses. Treat whatever's inside the parentheses as a single variable. So what you'll do, since your power in the numerator is greater than the power in the denominator, since the same rules apply, you'll take that base of a plus b, you'll take that to the 3 minus 2 power, which a plus b to the 3 minus 2, that's just a plus b to the first, or simply a plus b. That's all you would get, simply, is a plus b. What's the next one? Oh, good. We have w plus x to the fourth over w plus x to the fifth. Okay? Again, treat whatever's inside the parentheses as a single variable. In this case, the power of the denominator is bigger than that of the numerator, so you're going to have 1 as your numerator. Then you'll have your base of w plus x. You'll take that to the 5 minus 4 power in the denominator, which, we simplify this, you'll have 1 in the numerator, but w plus x to the 5 minus 4, that's w plus x to the first, or simply w plus x. So the answer you should get is 1 over w plus x. All right. X plus y times the quantity of x minus y all over x plus y to the second power. Alright. So, again, here's what you could do too. If it really helps you, you can do what's called a substitution. Because you're going to treat each of these parentheses as their own variable. I would say something to the effect of, let u equal x plus y, let v equal x minus y. Okay, that's a way you can do it. You can rewrite this then. X plus y is u. You can rewrite it as u, x minus y is v, all over x plus y squared. Well, x plus y is u. That'd be all over u squared. You're temporarily doing the substitution. What you get in your substitution will not be your final answer, though. It's important to put it back how it was for your final answer, and I'll show you that in a second. So what you have, first term would be u over u to the second. Then you just have that times v, because you have no v in the denominator, you just have it in the numerator. So, well, for the u terms, the u is greater, the power of the u is greater in the denominator than it is in the numerator. So you'll have 1 for your numerator over u to the 2 minus 1, all that times v. Which that would give you 1 all over u minus 1, that's just 1 over u times v. Which we multiply this, you would just get v over u. Now it would look like we're done, but the v over u is only our substitution. What you can do now, what you have to do, you let v equal x minus y, so you put it back as x minus y over the u, which is x plus y. So your final answer will be x minus y over x plus y. Sometimes doing a substitution helps. It can really help you when you've got polynomials going on in both your numerator and denominator. That can really help you, but just remember to put it back how it was like we did when you're done. Because your substitution, if you just left it as your substitution, you would get an incorrect answer. Alright, in the numerator we got r minus s to the second power all over r plus s times r minus s. Alright, so we got polynomials going on again in the numerator and denominator. If I were you, so pick something to represent the r plus s and something to represent the r minus s. Let u equal the r minus s. I would say that. Let u equal r minus s. We'll let v equal the r plus s. Alright, so now we've defined variables for substitution. Now your r minus s, that was u, you'll have u to the second power over r plus s, that's v, then r minus s, that's u, over v times u, which we can rewrite this as u squared over uv. We can rewrite that as such because we can, by the commutative property of multiplication, we can move the v and u around in the denominator. It wouldn't matter. So now you're going to split this up into the u squared over u times, you don't see a v in your numerator, so the numerator will be 1, v will be in your denominator. Okay? Now, u squared over u, well, the power in the numerator is clearly greater than the power in the denominator, so you'll take your base u, take that to the 2 minus 1 times your 1 over v, which is going to equal u to the 2 minus 1, that's just u, times 1 over v, which u times 1 over v, that would just give you u over v. Now, that's our substitution answer. We want our actual answer. U was defined to be r minus s, so you'll get r minus s all over what was our v, that was r plus s. So the answer is going to be r minus s over r plus s. So when you have polynomials going on, I highly recommend a U substitution. That's what I call it. Or a UV substitution, whatever you want to call it, just some form of a substitution. Now when you're able to do these more, you won't need to substitute. You'll know what to do when you have enough practice with it. I mean, I can do it without doing that, but I've been doing it for so many years. So, but when you're starting out, the substitution method's actually a great idea. So that's really all I have for this lesson. Next lesson, we're going to focus on finding the greatest common factor of monomials, because we're getting ready to really move into our factoring unit. So I hope everyone has a good night. Take care.